Welcome back to a new machine learning tutorial. In this video, we are going to talk about stacking classifier. We are going to talk about the theory behind the algorithm, and then we are going to code it using Python. Let's start coding. I'm in VS Code interface right now. You can use any code editor that you want. I'm going to be creating a Jupyter notebook named stacking classifier.ipynb, and I'm going to say select kernel 3.11.4. I will say stacking classifier, and let's talk about the topic. So stacking is an ensemble learning technique that combines multiple classification models. It's often referred as Bayes learners to improve overall predictive performance. So we are going to combine Bayes models. In stacking, the predictions from multiple Bayes models are used as input features for a meta model, like we can write it, or meta learner. Both get used, which makes the final prediction. The idea is to leverage the strengths of different models by learning how to best combine their prediction. So we are going to combine their predictions. Okay, so we have Bayes models and meta models, like this. So Bayes models, these are the individual models that are trained on the training dataset. Each model tries to learn patterns from the data and makes predictions. For example, you might use a decision tree, a logistic regression model, and k-nearest neighbors model as Bayes models. And at the meta model side, the meta model is trained on the predictions of the Bayes models. Essentially, the Bayes model's predictions serve as features for the meta model. The meta model then tries to learn how to best combine these predictions to make the final output prediction. Okay, so let's code it. I will say from scikit-learn.datasets import make classification, and we are going to create our data in this way. And I will say import numpy as np. Then I'm going to set x and y using make classification, number of samples 1000. Then I'm going to say number of features, I will say 20, number of informative is going to be 15, and number of redundant is going to be 5. So when I call the x, you are going to see the matrix we have, and when I call y, you are going to see the vector we have. We have a binary classification problem with the zeros and ones in the target, and we have x values like this. So continue over here. Now I'm going to apply train test split. I will say from scikit-learn.model selection import train test split. Then I will say xtrain, xtest, ytrain, ytest, and it's going to be equal to the train test split. We will pass x, y, and I'm going to give the test size of 0.2. So I'm just going to summarize the concept quickly, but if you don't know this topic and you want to learn about the train test split, you can check my machine learning tutorials playlist, where I have more than 40 videos just like this one and understand the topic better. So in train test split, we have training and testing sets, and we train our models with training set and we test them with the testing set. So xtrain and ytrain here are our training sets, and xtest and ytest are our testing sets. And we are going to train the model with xtrain and ytrain. Then we are going to make predictions using xtest, and we are going to compare the predictions with the true y values ytest. And this test size equals to 0.2 states that 20% of the data is going to be in the testing set and the 80% is going to be on the training set. So we have 1000 data points in here. 800 is going to be in the testing set for each, like xtrain, you can see 800, and at the test size we are going to have 200. So this is train test split. We train our model with the training set and then we test it with the testing set. Okay, so let's build the Bayes models. I will say from scikit-learn.linear model, let's include logistic regression firstly, like this. And next up, I'm going to say from scikit-learn.tree import decision tree classifier. And I will say from scikit-learn.neighbors import k-neighbors classifier. So these are going to be our Bayes models, and now we are going to initialize them like Bayes model 1. We can do that. Logistic regression. Next up, base model 2, it's going to be decision tree classifier, and base model 3 is going to be k-neighbors classifier. Next up, we are going to train these models. So base model 1 fit x-train, our training set, and y-train. We are going to do the same for the base model 2 that fit x-train, y-train. Now we are going to do the same with the tree, x-train, y-train. Now after training them, we are going to use their predictions to train the meta model, and we are going to have a final predictor, and I'm going to use support vector machines classifier for that. So we are going to say from scikit-learn.ensemble import stacking classifier. Next up, I will say from scikit-learn.svm import support vector classifier. So we imported support vector machines support vector classifier, and I'm going to define the meta model like svc support vector classifier. Now I'm going to create the stacking classifier. So I will say stacking model, and it's going to be equal to stacking classifier. I'm going to set the estimators like first up I'm going to give linear regression base model 1, and next up I'm going to say decision tree, and I'm going to give base model 2. Next up I'm going to say, actually it needs to be in this format like this. Next up I'm going to say KNN, and it's going to be the base model 3 we trained, base model 3 like this. So now what I'm going to do is we are going to set a final predictor in here after this. So I'm going to say final estimator, and it's going to be equal to the meta model that we initialized in here. So we have that right now. Let's train the stacking model. So I will say stacking model.fit x-train with y-train. So again, in here we trained our base models. Now we are giving in here one by one. Then we set a base estimator which we initialize support vector classifier on. And now I'm going to train this, and you can see we have logistic regression, decision tree classifier, KNN, and final estimator SVC. So we have our stacking model right now. Now we can make predictions with this stacking model. So I will say stacking model.predict, and I'm going to give the x-test in here. So we get a vector like this. Now it's time to compare this with the actual y values. So I will say from scikit-learn.metrics import accuracy score, and next up I will say y prediction is going to be stacking model.predict x-test. So we are going to have that vector in the y prediction right now. Now we can get our accuracy. So accuracy score y test with the y predicted values. It's 0.88. Great. We can use predict method for making predictions on the unseen data using stacking model right now. So we can use its like methods on like predict, and we can say x-test just like this one, or we can pass new values with 20 features. Like you need to give the features in the same order. We have 20 features on the x side, and if you give 20 values just like this one, we can do an example x0, and I'm going to copy this array. I'm going to come to here, then I will say it's going to be two-dimensional, so I'm going to be adding a bracket, and I will be passing this value, and we are going to get our prediction as 0. Also we can reach to that element in here, so it's 0 predicted. So if you pass x amount of features in two-dimensional format, you can get predictions from your model right now. And for saving this model, what you can do is simply you can say import joblib, and you can use joblib.dump method. Like you can say stacking classifier, and you need to give the file name like pickle, and we will give the stacking model in here just like this. So after making this run, you are going to have your model in this pickle file format in the Explorer, and you can use it by, let's say, loaded model. Now you need to do joblib.load from the joblib, and you need to give this file name just like this one. I'm going to copy it, and after doing this you can use your loaded model like with the same methods. With the scikit-learn model you can use predict for predicting the unseen data, and you will get prediction from your model. So you can save your model just like this. Let's summarize what we did in this video. So we started by talking about the stacking classifier. We talked about the base models and the meta model and how it works behind. Then we create the dataset with 20 features, 15 are informative, and then I showed you the X matrix we have in here and Y vector we have a binary classification problem. Next we use train test split. I talked about the logic behind the train test split. We imported the base models we have in here. Next we initialized the base models, we trained the base models, then we create the meta model, and we created our stacking model. Here is the structure, we trained it, linear regression decision tree, KNN, and final estimator is SVC, support vector machines classifier. We make predictions with it, and then we imported accuracy score for evaluating the model. We make predictions on the X test, saved it in Y prediction, and we get the accuracy score. Next up, I showed you how you can get predictions from your model by passing two-dimensional data in the same X structure. Then I showed you how you can save your model as pickle file and load it back in your apps and make predictions with it. Let's get to the outro. Thanks for watching this tutorial on stacking classifier. I have a machine learning tutorials playlist where I have more than 40 videos just like this one. You can reach to that playlist from the cards of this video. Also, I'm sharing a new data science video every week on my channel. You can subscribe for more data science content. Have a great day.